Hi, fifth graders. Mrs. Moore here today with you, coming from room 205. And we're gonna get ready here for chapter 3 today by gluing some resources in our math notebook and then practicing a really beginning skill with multiplying with powers of 10, playing a bingo game, okay? So I've attached some resources to the Google Classroom assignment. Hopefully you guys have those printed off. This is what they look like. And the kids here in the classroom are gonna be simply gluing them in their notebook here with us today. All right, so this is the first thing that we're gonna be gluing in our resource notebook. Now, all of these things can be titled multiplication resources on your table of contents, okay? So on the first page of your notebook, are you looking at your table of contents? Open your table of contents. Only half of you are doing that. Open your notebook to the table of contents, and we're gonna write in multiplication resources, okay? Multiplication resources. So go ahead and put that on your table of contents. This is the first item getting glued in there. I've already trimmed them up for the kids. And this is a chart that gives sort of some guidelines for what happens to a number when you multiply it times something greater than 1, less than 1. What happens to a number when you divide it by something greater than 1 or less than 1. So we'll talk about these connections later. Let's glue these in our notebook now. I don't know what that is. Multiplication resources. Anyone want help spelling the word resources? It's up on the board. Oh, good. Oh, yeah, that's right. It was on our planner page. Hurry up. What's on the whiteboard?
Do we glue this in right now?
Yes, glue this in right now.
And then we have other stuff on the page too.
Yes, I have 2 more things I'm giving you.
Can we glue it like that, closest to the top?
Yes, please. Try that for today. Ella, I'm gonna need you to take your math test, okay? So do you want to work on that in the fall? You're welcome to, because I'm gonna be kind of being loud talking. Please use that. Take it the whole time, but we'll catch you up on what's going on today when you get back. Okay. The next thing that you're gluing in it's going to be multiplication tables. And these are going to help us when we get into some heftier multiplication this chapter with like triple digit factors, quadruple digit factors. Sometimes some of you are going to be working on decimal factors and figuring out products of that. Okay, so these multiplication charts are for you to use. It's not cheating to use a resource table, okay? What we're going to be building in 5th grade is not only accuracy, but speed. So if this takes some of the pressure off of you figuring out your 8 times table times 9, you know what I mean? Find the answer, put it on the paper. It will help you move through the problem faster. So this is a little big. It's not going to fit like if you glue it in. So what I would suggest is cutting it across the middle, gluing one table on one side of the paper and the other one on the other side of the paper. You're going to notice that the top one is arranged like a table and the bottom one are arranged like lists of multiples, like your 1 times tables, your 2 times tables in list format. So this part actually comes into handy a lot when you're working on division, but are the same information on both of these charts?
Yep.
The same information's there. It's just arranged differently. Yes, Flori? I can't hear you, honey. We're writing the title multiplication resources on the table of contents, and you're writing what page number that these happen to land on. Was that your question? Nope, you don't have to write under them. They're just there for you to access when you're working on multiplication problems. Okay, Bristol?
So when you cut that in half, if you have room on the same piece,
Yes.
then you put that.
Yes.
You put it on it.
Yes, you can.
I don't have one.
The little one?
Yeah.
Sorry. Let me grab you that. I'll give you both at the same time. Got 'em? Okay. Cut this one in half. I just ordered food because we don't have any food at our house. I don't have time to go shopping. No.
I got banana bread.
You guys, your teachers are working harder than they ever have in their entire lives right now. And their kids are suffering because of it.
This one. And this is full of Garden City. And they give out free documents. I know. I also
Does everyone have multiplication charts?
Yes.
Yes. All right, so all my friends at home, you're working on building your resource notebook, right? Gluing those items in, just like we're doing here in the classroom, so that they can be of service to you throughout the chapter and anytime you feel like you need them. So how about while we're gluing, we just chat a little bit about something fun, cutting, gluing. And guys, feel free to unmute or type in the chat box if you'd rather. Let's talk about hot topic, like, what's your favorite thing to do in the fall time? Is it like cider milk, carving pumpkins? What's your favorite thing to do in the fall time? Oh, Trevor, what's your favorite thing?
So every year we always get so much leaves, and you always get a whole bunch of leaves, bring them to the car, and go to the cider mill.
You bring the leaves with you to the cider mill.
And then you find the nearest person and dump the leaves on them and say, "Happy Halloween!"
Is it the trick of the trick or treating
Yeah.
when you dump the leaves on them?
And also, and then you get pumpkins,
Mm-hmm.
and you get some cider, and you get
Mhm.
apples.
You know, we've tried to keep pumpkins at my house, but guess what? Squirrels.
Oh, yeah.
Squirrels destroy all efforts I have to make my house look like a fall, beautiful. Yes, Flori? And they leave them be because it probably tastes gross to them. Oh, interesting.
But sometimes the squirrels still eat it and then they die.
Yeah. Aubrey's typing in the chat box here. She said that she likes fall time because it's the beginning of like football and cheer season, and carving pumpkins is fun. What do you think, Ryan?
My favorite activity is going to
Three Cedars Farm. Who's been to Three Cedars Farm before? Who's been there? That's a nice place. Yeah? That's a huge place. You could spend like the whole day there trying different things.
And we spend time there, and what we do is we spray paint our pumpkins to look like characters, and then we do like a little play with them.
Oh, that's silly. Are they like regular size pumpkins, or do you have like little mini ones to be?
Different sizes for different characters.
Okay, all right. Michael in the chat room is talking about how he loves when the leaves change colors, and especially on sunny days, Michael, right? It's like amazing. It looks like the world was just painted with a paintbrush, right?
Oh,
And one tree, like a maple tree, can be like 4 different colors all in the same tree. Like the center of it's more green, and then it's yellow, and then orange, and then brilliant red at the tips of it. It's really beautiful.
my banana bread fell.
Oh, darn. All right, Joe, what do you like?
I was adding on to Michael's.
Sure.
When I went up north, we went to this thing called the Tunnel of Trees. And there's
Tunnel
like
of
so
Trees?
many trees, and you like drive around.
You drive through it,
Yeah.
and the colors are probably really awesome.
Yeah, it's like 14 miles long.
Does that happen to be on, do you remember the number on the road? Was it M22?
Oh my
Was
God,
it M22?
So pretty. I think it was M19. It was M19.
Yeah. We are, this weekend, you guys, I'm going up north to M22. That's right, like right over here in Frankfort, Michigan. We are gonna kind of stay in this cabin and enjoy the nature. There's no TVs. It's just,
The walls made out of electrical wires.
yeah, you can see all the wires in the walls, and it's just Crystal Lake in Lake Michigan. It's really, really relaxing. So,
Here, this weekend.
yeah, I'm gonna be leaving right after school tomorrow. We have a day off Friday, so we're gonna capitalize on that extra day and head up north. Okay, I have time for 2 more. I've got Andreas said that he was talking about his sister went to college up north, so I bet you the drive up north was really beautiful. And Zoe's mentioned that it's not too hot, not too cold, and like in the morning you get to wear your cozy clothes, but then by the afternoon it's warm again and you can run outside without a jacket. That's really nice. So in the classroom here, I have time for 2 more, Dante and Ella. Okay, Dante, go for it.
I like fall because it's one season closer to being winter break.
You like winter?
Yeah, I like.
And you like the winter break is coming and you get a little time off school, right? Okay, Ella, go for it.
I like Halloween and November 7th. Halloween is you go to my nana's house and you get some pizza, watch some scary movies, and celebrate my grandma's birthday.
Cool.
And on November 6th, I visit. Yeah. And because one time when it was my birthday, they decorated the whole house by the
Oh my goodness. Who has a fall-time birthday in this classroom? Fall-time? Oh, only a couple of you. Any of you guys have a fall-time birthday? Zoe has a fall-time birthday. That's it? Okay. So let's get, now that we've glued and trimmed our resources, there's one chart. Hey, now we're going to talk math. There's one chart in particular we need to look at really closely today, and it's the itty bitty one. Everyone look at the itty bitty one. Can everyone look at the itty bitty one? Shh. I organized this chart for you so that we could start to understand how the operations of multiplication and division are related but opposite. What do you notice about this chart? When, look in the first column, it says when multiplying by a number, what's that symbol mean when the open mouth is towards the front? What's that symbol mean when the open mouth is towards the front? What's that mean? Go ahead, say it. What's it mean? Greater, yep. When you're, yeah, thank you, Michael. When you're multiplying by a number greater than 1, what happens to that number? It gets bigger, it increases in value. Let's try an example. Let's say I have a 5 and I multiply it times a number greater than 1. How about 5? What happens to the 5? 5 times 5 becomes 25, and it increases, right? So a number gets bigger when you multiply it times something greater than 1, right? Look at the dividing by something greater than 1 though. What happens when you divide by something greater than 1? What happens when you take, let's say 30 and you divide it by 5? What happens to 30? What happens to 30, Madeline? It gets what? it gets smaller, right? 30 divided by 5 is only 6. So 30 became a smaller number, it decreased. So multiplication and division are exact what of each other? They're exact opposites of each other. So that's why some of these things on the chart you're noticing are exact opposites. Now, the column here where it talks about when you multiply by a number less than 1 and divide by a number less than 1, those are things we're going to learn about throughout the school year, but more so in 6th grade. I gave this same anchor chart to my 6th graders, okay, because they're going to be using it as well. And where I see some of you ready to push into 6th grade stuff, we're going to go there, okay? But for today's class period, we're going to be focusing on just the multiplication side, okay? Just the 2 in the front, the multiplication side. That's what we're going to look at today. When we multiply by something greater than 1, what happens, class? Put your fingers. It increases. And when you multiply by something less than 1, it decreases. Well, what's something less than 1?
Oh.
Russell, what's something less than 1?
Negative.
Maybe negative. What else, Flory? What do you think? What was that? Okay. What do you think, Trevor?
0.
0 is less than 1 for sure. And if I multiplied anything times 0, what would happen? And that's lower than it started with, right? Okay, Lucas, what do you think? Decimal. So what do you mean by decimal? Like a part of a number?
Yeah.
Huh. Maybe like a fraction or a decimal. Is that less than 1? Yeah, so if you multiply a number times a fraction, it gets smaller. It's basically a fraction is a form of division. So if I said take half of 10, what's half of 10, everyone? 5. What happened to the 10? It got smaller, right? So division and multiplying times decimals is very related, isn't it? It's actually the exact same thing. It just has a different kind of format to it. You're going to learn how multiplication and division are complementary. They're exact opposites of each other. Do you know any other operations that act that way with each other? What other operations are exact opposites? You can kind of like check the other one with the other one. What do you think? What do you think? Class, what do you think?
Addition and subtraction.
Addition and subtraction, right? They have that relationship where they're exact opposites of each other. All right. I'm going to demonstrate something on this little whiteboard behind me because when school started, you guys remember how the big whiteboard wasn't working? And so I had to like think on my feet, like, what can we do instead of use the whiteboard? Oh my goodness, the big whiteboard in the classroom's not working. So I brought my little one here with me today. And what do you see on this number line or on this board? What do you see on it? It's not a number line. Sorry.
Number names.
Number names. Okay, keep going. What else do you see?
Tenths.
What would you call this if you saw this? Place value chart? Sure. Is this a place value chart?
Yeah.
Talk to me about the different colors that I used. What did I use? What are you noticing? Mackenzie, can you see it from back there? Ella, can you see that from back there? Yeah. Okay, what's the difference in the coloring that I used, Mackenzie?
The purple is greater and the black is decimals.
Oh, opposite, I think. Because if the decimal point's right here, we have ones, tens, hundreds, thousands going this way, right? And then when we go backwards, we have tenths, hundredths, thousands. Do you see that? Okay. So yeah, I definitely did that on purpose. I put my whole numbers on this side, and I put my decimal values on this side. If you looked on your place value chart in your resource notebook, what power of 10? This is a tricky question, so you need to do your place value chart. What power of 10 goes with hundreds? What power of 10 goes with hundreds? What do you think, Leah? Yes, very good. Oh my gosh, 10 to the power of 2, or 10 to the second power, right? What goes with thousands? John, what goes with thousands? 10 to the third power, which means it's literally 3 steps away from the decimal point. That's what 10 to the third power means, is if I were at the decimal point, I'm 3 place values away. Does that make sense?
Yes.
So what we're going to work on today with this bingo game is applying a power of 10, multiplying by a power of 10, and taking a number, shifting it that many place values over. Okay? So let me write one example up here on the board, and then I'm going to pass out the bingo game for us to do together. All right? Yeah, because you might need your place value chart to help you along, but we'll see how we can do this. All right? Here's a number that I'm going to give you. It's 6.34. Are you able to see that from back there, Kylie? Ella? Are you looking up here and not with whatever's on your desk? Well, then you need to make yourself maybe easier to see, maybe stand up or against the wall there. You can't.
I can see the numbers, I can't see the word.
Then stand up from where you are. Okay, now can you see it? And what are you going to do about it?
Yeah.
Maybe move closer? Okay. I don't want you to miss this. Alan, do you need something right now?
Just pointing out.
Maybe she meant to do that.
Maybe she just meant to do 10,000. Yeah, maybe she ran over.
Oh, thank you. Wow, good eye. I was getting ahead of myself. Thank you, Alan. That's what happens when Mrs. Moore goes to bed at 2 o'clock in the morning and gets up at 6.
I have to get up at 6, but I will actually not.
I'm never done with my mommy jobs or teacher jobs. I'm never done. If I took this number, 6.34, good idea, girls, so that you can see better. And I'm going to pretend that it's sitting here on the number line, 6.34. 6.34. Do I have my number positioned in the right spots? 6.34. If I multiply it times 100, how many place values am I shifting it over, class? 2, because 100 represents how many powers of 10? 2. So I'm going to go like this. A 1, a 2. So what happened to the 634? It just literally shifted over 2 place values. The 6 moved over 2 place values. The 3 moved over 2 place values. The 4 moved over 2 place values. So where is the 6 sitting now? In the hundreds place. Where's the 3 sitting now? Tens place. Where's the 4? In the ones place, right? So I would say the answer for 6.34 times 100 is 634. Okay? Let's try another one. I'm going to start it at 0.634 times 1,000. Whoa. Oh my goodness.
Oh.
Problem on the set. We lost some place values. Wah, wah, wow. Take 2. Okay? So 0.634, if I place it here where it belongs on the place value chart, and I multiply it times 1,000, how many place values am I shifting it, class? 3. Which direction? Getting bigger, right? Because when you multiply times a number that is greater than 1, is 1,000 greater than 1?
Yes.
What happens to this number? It gets bigger. A 1, a 2, a 3. What is the answer?
164.
634, right?
I have a question.
Yes.
So, if you were to divide it, you would go to the right.
Did you hear what Maddie asked?
Yeah.
She goes, if I was dividing by 1,000, which we aren't doing yet to chapter 4, but if I were dividing by 1,000,
Yes, you would.
what would happen to that number? It would go
Small.
that way, right? And get smaller. That's why I gave you the full chart today, so that when you're ready to start making connections like that, you got your tools, okay? On this game that we're gonna play, you're gonna see that you have a bingo board with numbers and then towers of 10. I'm gonna roll 2 dice. It will give us a number to place on the place value chart and then a power of 10 to apply to it. Does that make sense?
Yeah.
So we're gonna see where that number happens to land based on what power of 10 we've multiplied it by. We're gonna start with board A, and probably that's all we'll have time for, but let's give it a try. Board A, and if you happen to have this at home, the scoring guide, I'm probably not going to write on this, but feel free to at home, because I'm gonna be writing up here on the board. So see those equations I'm writing? You can write them on this game board if you have it printed off, ready to go. All right. Yes, Leah?
If the number was like 6.1 times 10, would the 1 just be in the 10?
You would take the 6.1 and just go, boop, move it over 1 place value. If it was 6.1 times 1,000, how many place values do you bump it? So it go, a-do, okay? Some people like to see, or say, instead of the number moving, which it is, they like to pretend the decimal point looks like it's moving, right? Doesn't it look like the decimal point's moving? Kind of, yeah. But we know that it's kind of like we're on the earth. It looks like the sun's moving, but is the sun really moving?
No.
No, we're moving, right? The number's moving, but it looks like the decimal point is moving. Okay, so I'm gonna have someone pass these out for me. Looking on board A, you wanna pass this out here, Bristol? Thank you.
So,
I'll take the extras.
So if we do 0.634 divided times 1,000, so we would just go basically to 3 up.
Yes. I'm just giving my board a little facelift here before we get started. But you have your place value chart in your notebook if you ever are needing a little support. We're not doing dividing today, all right? Just so that you're aware. We are just looking at multiplying, and we're just looking at game board A right now. Okay, game board A.
Miss Moore?
Yes, Isabel?
Miss Moore?
Yes.
Okay. How would we, so for, because you said we can just write it, if we had it already printed out, the game board A.
Yeah.
For the numbers you're writing on your whiteboard, would we write that, would we write that in the slot in number 1 under factor, factor, and factor?
I will demonstrate it. I'm gonna do it on my paper here, and I'll just hold it up for you, okay? So that you can see what it looks like, but I'm not gonna pass this out in the classroom because they have enough things on their desk right now, okay?
Okay, and also it says multiplying decimals dice game.
Yeah.
I have dice, but how many would we need?
2.
2.
But I'm gonna do it with you. Look, I've got dice here on my phone. We're gonna do it all together.
Okay.
Okay, so you don't need your own dice. Thank you so much. So when we play our multiplication game, you're gonna need maybe a highlighter or something to stamp your game pieces with. I really wish I could bring like Mr. Juicy's for everybody. Maybe we could do that one day. That would be fun, right? Mr. Juicy's are these bingo stamper guys that we use in the classroom. Sometimes the kids really like them.
Give us at the end of the year, all of us a bunch of discounts.
Aw, that would be a good idea. We could, yeah, you guys could all get your very own Mr. Juicy. What would you think about that?
Awesome.
Yes? Okay. Can you get what you need right now? I have to kind of keep teaching, and then I'll help you later. Okay?
You know, you should ask us
Are you ready? We're going to work on game board A, everyone. I have my dice here on the screen. So are you ready to see what our first problem will be? Okay, here I'm rolling. We got a 4 and a 2, or a 4 and a 3, I'm sorry. So I'm looking at the 4, and what numbers are written there? 0.89, right? Board A.
Wait, what was it?
It said, I'm not answering that question anymore.
I got it.
Stop talking. It says the dice were a 4 and a 3. So I'm looking at the 4 in the first column, and what number is there? 0.89, right? Now, if I look in the next column, a 3 means 1,000. So that's like saying I'm taking 0.89 and I'm multiplying it times 1,000. I want to know where will it land. How many place values do I move when I'm multiplying times 1,000, class?
4.
Not 4. 3. Look at how many zeros are on the back of 1,000. That should give you a little hint. 3. And which direction am I pulling this number? Bigger, because I'm multiplying times a number that's greater than 1. 3 place values to the left. Here we go. A 1, a 2, a 3. But wait a minute. An 8's in the hundreds, a 9's in the tens. What's in the 1 spot?
0.
Oh, a 0. So I'm looking for the number 890. Look for the number 890. So if you were writing the factors on your little game board, Isabella, yes, highlight it. This is what you would write.
Oh, okay, thank you.
The factor is 0.89 times 1,000, and it will equal 890. Now, this would be something cool to put in between them, are just like your multiplication symbols, equal sign. That should help.
Can we color in our free space?
Yes, color in your free space. And I found 890, did you? It was right underneath it. Okay, let's do the next one.
Wait, what's my number? Wait, does everybody have the same game board?
Yes.
Yeah.
Okay, the next one we're trying, it says the dice is 2 and 6. So let's look at 2. What do we have for 2? 1.4, right? And what's the power of 10 we're multiplying the 1.4 by? The 1.4 is times what number, class? 6 is, it says 2 and a 6. So look at the 6 on the other side. 1,000. So we're doing 1.4 times 1,000. Where would 1.4 land if it was multiplied times 1,000? Let's move it. How many place values? 3. 1, 2, 3. Where did it land? In the 1,000 spot. 4 is in the hundreds. What's in the tens?
0.
0. What's in the ones? 0. So it becomes 1,400, right? Wow.
Found it.
Did you find it?
It's in the very right corner. So far, now we're in the bottom line.
So that's what it would look like on your little game board if you were keeping track.
Why doesn't somebody get to be there? Then everyone.
Then we say, hooray! Does everyone remember what Mrs. Grabarkowitz would say if something? There's a bingo in the cafeteria. Yes, she did. Okay, I'm going on to the next one. She was the old assistant principal. And she would say, like, if you forgot something at home, she would say, it's an old bummer day. Do you remember that?
Like pajama day?
Yep. Okay, the next one, I rolled a 6 and a 3. A 6 and a 3. So if I'm looking at the 6 and a 3, that means 92 divided by, ooh, 1,000. So look at my 6. Here's my 6, position where it's supposed to be. 92. Oh, I've divided. Times 1,000. Which direction do I move it? Bigger. How many place values, class? 3. Why? Because 1,000 represents 10 to the 3rd power, means shift it 3 place values over, a 1, a 2, a 3. So I gotta fill these guys up with zeros, right? Wow, what's that number?
92,000.
92,000. Did you find that one?
Oh,
Oh, it's just to the left of the free space. 92 times 1,000 equals 92,000. You getting the hang of this? Yeah? Okay. All right, you ready? Yeah?
All these boards look different because it's like a video game.
Yeah. Yeah, I have more game boards for division and decimal number. I have tons more game boards. So now that we know how to play this, we can practice using different techniques. I got to keep going. A 5 and a 2. Class, a 5 and a 2. So a 5 and a 2 would look like a 6.2 and a 100, right? A 6.2 and a 100. Here's 6.2. If I multiply him times 100, where is it going to land? 6.2 times 100. How many place values, class? 2. 2 place values. A bump, a bump. And then what gets filled in that extra empty spot? A 0. So did you find 620?
Yeah. Oh, that's another diagonal. I found it.
No, it's not.
It is, but you can't get a bingo. It's not a bingo. It's a connection. There's nothing connected.
Oh darn, yeah, we have just 2 in a row so far. All right, next one, 6 and a 4. Oh, this one's interesting. A 6 and a 4. A 6 and a 4. That's a 92 times 1. What's 92 times 1?
92.
What's the answer?
92.
92. So there's no shifting on the place value chart.
920.
92 times 1 is just 92. Tell me the name of the property.
1.
What's the name of the property? Identity. Because the 92 is showing its identity on the other side
Wait, is it
of this
92?
vector. Mhm.
How are we getting 92 from 6.4 and how are we getting 1 and 100?
They're not related. We're just rolling which number we're gonna work with.
How do you
I just rolled it. I have dice rolling here, Madeline. And then whatever one the dice land on, that's the one we're working on. So yeah, that's the one I picked just now. I rolled a 6 and a 4. So that's why we did the 6 and the 4, okay? Here, let's looks like we have time for maybe 2 more here. I got a 5 and a 1. A 5 and a 1. So what's the number with the 5, guys?
6.2.
6.2. And what's the number with the 1? Okay, 6.2 right here, times 10. How many places am I shifting it? One. So that number becomes what?
62.
62. You got it.
Oh, I'm not the, I only need 2 more.
Oh, we need 2 more, right? So before we wrap this up, I just want you to turn over your bingo board and look at the back, because you could play this at home with 2 dice, but notice how the powers of 10 aren't written like 10, 100, 1000. I have them written as exponent values, right? 10 to the 2nd power, 10 to the 3rd power. So that might be something interesting for you to try, okay? We're gonna play this game with different numbers, division in the future. Oh, did you enjoy the game today?
Yeah.
Moving it through the place values? When you,
2 more.
okay, I'm not leaving until you answer my question. When you multiply times a number greater than 1, what happens to the number?
It gets bigger.
It increases. Well done. All right, kiddos in 5th grade, if you participated in today's assignment, show me your bingo board and you'll get your full points for participation. Nice, Michael. I see yours.
Our other stuff.
Are you guys, yep, all of you people here in the classroom are getting your points. I see Andres, I see Aubrey's. Oh, nice job. Good job, Levi.
We fill in the front. No,
Nice job. Did you guys have fun today?
no.
All right. I will see you next time, okay? Bye.
We fill the top.